Hello guys. So now we're going to continue in our, set of exercises and practice for chapter 10 in our SM2 class. So this time I'm going to talk a little bit about section 10.7 circles in the coordinate plane. So this is the first of a couple of exercises I'm going to upload. So let's begin. Just a quick review. The equation of a circle on the coordinate plane is presented here in front. X squared plus y squared equals r squared. This is the equation of a circle whose center is located at the origin. It means the coordinates 0, 0. The thing is that it's just one of the many cases that we can see whenever we are drawing or sketching a circle in the coordinate plane. So I prefer that you remember this, which is the standard form of a circle on the coordinate plane. This is indicating that x minus h squared plus y minus k squared equals r squared, indicating, and remember these minus signs over here, that the center is located at the coordinates hk, and the radius of that circle has a length of r. Okay? So with that in mind, what we need to do in this exercise is we are given the equation of a circle, and we have to find the center and the radius of that circle. By the end, also, I'm going to graph that circle as well so you can see how it works, okay? So let's begin. So we are presented with the equation of that circle. Remember, and the way we recognize that, it's because it's a polynomial degree 2 for both x and y, and then the other elements of the polynomial are the linear terms and the constants. So what we want to do if we need to find the center and the radius of a circle is that we're going to try to convert this expression into something like this, like the standard form, which means that x has to be accompanied by a given value, presented as a binomial form squared, and the same thing happens with y. Both of them are going to be presented on the left side of the equation, and then the remaining elements are the constants, have to be on the other side, and they will represent the radius. So we are going to do some algebraic manipulations to make it happen, okay? So the equation we have is x squared plus y squared plus 6y minus 2x minus 6 equals 0. So we are going to rearrange all the elements of this equation so that we present it like this. So the first thing I would say I would do is this. I'm going to keep x squared over here, but then right after that I'm going to put next to it the linear x term, so x squared minus 2x. I'm going to keep this space, and I'll explain that in a little bit, and then I'm going to continue with y. This is plus y squared, then plus 6y. Same thing here, I'm going to keep a space, and then that equals, look at this, we have a minus 6 here, but I want to see it on the other side, so it's going to be a 6. Now what happens? What I pretend to do is that this is an expression that we have here as a quadratic and a linear term, and I want to make it or the display is going to be as a binomial, that is a square. This is where we need to remember when we learned how to complete the square, because the intention of completing the square was to represent polynomials into a binomial square. So in this case, we need to remember this. When we have this type of expression, we are going to focus on this term. This is what we call b, negative 2. So now we just keep following the procedure we learned over there that time. B halves is negative 1, and then b half squared is 1. And I'm going to do the same thing here in a moment, but this means that what I need to add here is this one. So I'm going to add it, plus 1. Remember that every time you add something on the left side of the equal sign, you have to add it on the right side as well to keep the balance of the equation. So since I don't have a lot of space in here, I'm going to write it here, plus 1. And I'm going to do the same thing here. So I'm going to focus on this expression where this positive 6 is b, then b halves is 3, and finally b halves squared is a 9. This is the expression I need to add here, plus 9. Since I added 9 on the left side of the equal sign, I add it on the other side as well. Here we are. So now we need to rewrite this expression and with all the terms implied, okay? This is the trinomial here, perfect square trinomial. This is the second perfect square trinomial in terms of y, and this equals 9, 7, and 9 is 16, okay? So I want you to focus on these two trinomials. This trinomial right here and this trinomial right here. Since these two are perfect square trinomials, because I made sure that I completed this square, I'm going to factor these two because now they will be represented as this, okay? I need to keep in mind b here and b here, which means that I now have x, it was a negative, so I have x minus 1 squared, plus, now I take this into account with this 3 over here, I factor, and that's it. This is a 16 that if I want to keep in mind this expression, 16 is actually 4 squared, okay? Now, I started from here, and eventually I came up with this expression. This expression tells me that the center of this circle is located at HK. What is H? H is 1, and K is -3, and the radius of that circle is r squared here, so this is r, so r equals 4. Okay, so I'm going to pause this a little bit. Actually, yeah, I'm going to pause this. So what you see now is that I drew a coordinate plane in order to graph this circle. This circle is located, the center of this circle is located at 1, -3, which is right here. And since I know the radius is 4, I made sure I located some points 4 units away from it. And you're going to excuse me, I'm not the best at drawing circles, but I'm gonna try, because now I know that this is the circle that we're looking for, okay? So this is how it goes over, on the coordinate plane. So this is an approximation of the center of the circle and the corresponding center you have here. And then you're done with the exercise. You can see center is located at 1, -3. The radius, this distance here, is 4 units, okay, everywhere. And that's it. We're done with this exercise. Thank you very much.